Hi guys, it's Nico, and in this video I'm going to show you how to quickly learn Pico C, even if you've never coded before, with the help of Chat GPT. Let's get into it. First thing, what is Pico C? As soon as you Google it, you're going to see a lot of information about Raspberry Pis because it's a coding language that is used for microcontrollers predominantly. Now, it's used for a lot of IoT projects and it's used for things like Raspberry Pi. And in our case, it's also being used by the Loxone mini server. In this case, it's being a programming block, a function block basically inside the whole API that we're using. Now, with PicoC, you can do quite a lot. And if you are being clever about the way that you're using memory, you can keep everything quite lightweight. And because it's based on C, it is a great tool to have in your toolbox because if you know one, it's probably going to be very easy to pick up the other, and so on and so forth. Now, what we're going to do today is we're going to be using VS Code, and I'm not necessarily going to show you how to download VS Code and install it. There's plenty of information online, and I'm pretty sure that you're more than capable enough if you're already looking at a tutorial of this type. Now, a lot of the information from today I've already gathered from the documentation online. So if I just go and search for the Loxone documentation, or if I search for Pico C documentation, you can see all the information in here that you need, all the basic input and outputs, and some of the built-in features and libraries that are available in Pico C. And we are going to be using ChatGPT. And with ChatGPT, the one thing I've done in here, I obviously have a paid version myself. However, this version that I'm using for the tutorial itself is the absolutely free one. So you can just go in, register with your Microsoft account, a Google account, Apple account, and so on. And you can just get a free account up and running today at no cost. And now with that version of GPT, it's still going to be powerful enough, in my opinion, to teach you or kind of assist you along the way while you're learning how to use Pico C and how to learn C in general, or any other programming languages for that matter. So now that you have downloaded VS Code and installed it, we want to open a new window. And when VS Code starts, it's probably going to look very similar to this. It might ask you for a couple of different things. Just give it the information it needs. But then we're looking for this for extensions. You can also press Ctrl-Shift-X and it's going to open it up. And if you search in this box and just type in C, C++, you're going to be able to find this extension at the very top, which is the C or C++ extension. And that is basically going to give us all the tools for running our code, debugging our code, and making sure that it looks nice in our environment. Now install this one. Once ready, it might ask you to reboot Visual Studio Code or your PC. Do that, and then let's go to the next step. Next step would be to obviously start a new project. Now there are different ways to go about it. The one that I prefer is I usually make a folder somewhere, and then I'm going to open that folder. Now there is already something in that folder, but that's for our later use. It's obviously going to be a completely empty folder in your case. So I'm going to come in here and going to open a new folder. I'm going to go to my desktop and open it up. And if I had any files, it's going to automatically read them through. Now this is something that I've created for your own use, and basically it's a cheat sheet because obviously we're going to forget the syntax at some point. So it's going to be nice to have something on the site where you can open up and you can remind yourself, right, I need an integer, I need to print this way, and so on. Now we're going to come up here on the top, or in your case it might say new file in here on the left, but you want to create a new file, and we're going to call it first script.c. And whenever you name it .c or whenever you give it .c extension, is obviously going to know that it's looking for a C script and it's going to execute a C script in here. Now, the very first thing that I'm going to show you is obviously going to be how to compile some very, very basic code, but I also want to get you into the habit of using something. I will show you the both ways around it, and then we go through it. And here I have a free version, again, of ChatGPT, and we are going to be using it for what we're doing today. And I'm just going to tell it one thing: create me my first C code. That's it. So it's going to make a small hello world code in here, and I can simply copy this, come back here, paste that information, press Ctrl S to save the file, and now you can press that button in here or press Ctrl Alt N to run it. And once it runs, it's going to give you an output. Now, this in here is basically all the code that you require to create your very first program. And basically what this is going to do is going to just print out to the terminal, hello world. So basically saying that, hey, we're here. If you want to start playing around with your very first program, you can just come in here. Instead of saying hello world, you can say this is my first script, and it works. Press Control S to save again, run it, then you'll see that this is my first script and it works because it outputs to the terminal. But now, what is this mumbo jumbo of information? What is that syntax? Well, let's go and break it down from top to bottom. And I'm going to make it a slightly different one just in case. Now, in here where it says include stdioh .h, basically we want to include a few libraries whenever we work with information. For example, if you want to be working with time information, you might need to include a Unix library. If you want to learn work with maths, we might have to include maths libraries. The libraries are quite simple. Basically, when it comes to C or any other programming languages, it's very vast and there's a lot of information that it can use. There's a lot of libraries that it has. And if you were to include all of them at the same time or just have them working in the background, that might make our programs very heavy. So we only want to use the libraries that we really need. However, a small difference that might be in Pico C is that with some processors and some compilers, you don't necessarily need to say which libraries you need to include. Like for example, in Loxone, you don't need to say whenever using the programming block which library you're including, because that's already pre-included or kind of pre-compiled with the Pico C code in the first place. So we're going to include the basic library in here. Now, there's different ways to declare your very first function. There's int, there's void, and so on. But basically, it does depend on what type of output you want to get. I'm just going to use void for now. I'm just going to call it void main. I'm going to give it its brackets and the curly ones as well. Now, this is basically the syntax that you're going to require whenever you start any program, any function. So if you want to create a function that maybe outputs a number at the end, you might say an integer is what you're looking for. Let's say h. What is your h function, for example? The syntax is going to look exactly the same. And then your code, all that information goes in here in the middle. That's where the meat of the code really sits. Now, we're going to be using the main one because obviously that's going to be the main function that we're going to be executing. And for main, I'm going to just make it very, very simple. And we're going to start top down. We're going to be looking at variables. Now, when it comes to variables, you have a lot. You have integers. I'll say int age, and I'll just put my age in here. There we go. Now, that is just me declaring a variable, and it's basically saying that in that age variable, store that information, store that 26. And int simply means an integer. I'm looking for a whole number, not for something with decimal places. If you want to, in here, what I do strongly advise everyone, whenever they get to start coding, is get into the good habit of leaving notes for yourself. So if you do \\/ in here, this is now a comment and it will not have an effect on my code. So basically in here, whenever you do that 2 dashes or 2 forward slashes, you can put the information, say integer equals whole number. And that's basically as much information as you need. And then if you want to give yourself even more information, you can say semicolon is required to end the line. There we go. Now, if I save this in, press Ctrl S and press the play button, absolutely nothing is going to happen, and that is okay, because we've actually not told our program to print out to the terminal. So for example, you can have a lot of functions that are happening in the background, and these functions are not maybe going to be necessary for the user to see. So maybe you don't want to see every single computation, you just want to see the end result. That is exactly why, if you don't explicitly tell the program to print something to the terminal or output it to a terminal, it's not going to. What we want to now look into is variables. And I'm going to just tell it, give me all of the basic variables as examples. And I want to have comments in the code. And I'm going to give it a little caveat. Now, this is just going to make our next step easier, but make the main function a void instead of an int, because we're not looking for it to return a number or output a number. We're just looking to give us the information, and then we can run it in here. There we go. It's adding a lot of information. Maybe we don't need all of it, but let's see. I'm going to copy that code. It's going to give me an explanation. Obviously, again, quite useful for yourself. But I'll paste it in here. Control S to save it in. Run the code. And it's now supposed to output, there we go, all that information. Now, you can see there's different variables. Now, this is basically what a variable is. So my integer is going to be an integer. So this can be, for example, age. And my age is, what, 26? So basically, I'm saying that in that age variable, I'm going to be storing a number. And because I've declared that it's going to be an integer, that integer is a whole number on its own. Then a float, for example, can be, let's say, temperature in here. And temperature, in this case, is going to be well, let's say it's 22.5 degrees outside. I don't need that F in here at the end to identify it as a floating point. It's fine. And it doesn't matter, again, when it comes to this, it doesn't matter if it's uppercase, lowercase. Usually people like to have naming conventions. So for example, temperature outside or outside temperature is going to be spelled like this and so on. In this case, let's just keep it simple. Double is basically a more precise float. I was just going to remove this one for now. Character. Obviously, if you just want to output a single character, the most common ones are going to be booleans, true or false. And in here you can also see a boolean. Again, don't need this for now. Let's use the character and just set it to T. And then a string in here. So I'm just going to call this single character. And I have a string in here. And that string is going to be hobby. I'm just going to put in here automation. There we go. Now if I save this in, you're basically able to see the same outputs. Run the code. Undeclared, undeclared, undeclared. Yes, we forgot for the prints. So the float we are using, the integer we are using. However, you can also see that it's looking for a little bit more information. And we've already changed their names. So for example, in here, it's going to be age. My float is now temperature. My double, we have no double, so you can delete this. My character, we do have a character, and we called it single character. And my string, again, we do have a string. Our string is hobby, and that's fine. Boolean, ignore for now. You don't need all of this. The if statements are going to come a little bit later. Save this in and run the code. So now we can see integer value is 26, float is 22.5, character is T, and the string value is automation. Now, what you can see in here is obviously us printing that information to the terminal. If I was to, for example, comment that section out, or I want to comment that section out, or that section out, basically let's say all three of them, and save it, the only thing that will be displayed is going to be the integer. And if I do that, there we go. The only thing out to the terminal is going to be the integer value. That is obviously because in a lot of instances, you might want to compile some information or want to run some configuration in the backend, but you don't necessarily want to give that information to the user, or you don't necessarily want to forward that information to the next state or anywhere else. You just want to use that variable or that information within the code. And once compiled, you just want to output maybe one string or one number or one information. And that is basically the print function. It's outputting to the terminal, it's outputting to, let's say, the end user in some situations. about the information that you want to present them with. Now, what I want to look at is how these strings are made, and we can look at, for example, the integer. So this in here, where it says integer value, is basically just some information. So whenever you're presenting it to the user, it looks nicer. So for example, I can say my integer, aka a whole number is, save this in, save it, there you go. It's outputting basically my integer. And there is a little bit of syntax in here that is being added, and I'm going to show you by doing this. So if I print it 3 times, you'll see it 3 times on new rows because of that \n. It basically means add the information on a new row. If I was to delete the \n, run it, there you go. All the information is going to be on the same row. So it's quite nice to have them in there just to keep things neat. Now then comma h and that %d. Now %d basically means show me that decimal, and it's using that decimal afterwards. So we're saying the information after the comma is our variables that I want to put into my string. So for example, if we were to look at, let's say, automation of the character, I'm going to create the string by saying printf, and in here I'm going to say my hobby is, and now it's going to be percentage, and now in here I'm going to have a slightly different syntax. So it's not going to be D for decimal, but it's going to be S because I want to output the whole string. And now with that string, if I want to put in a new row, I can also do this, or I can also put a dot in here if I want to end the sentence, comma, and this is again my hobby, semicolon to close it off, run it, there we go. My hobby is automation. So this is how you basically manipulate strings and play with all that information. Now going back to that cheat code from earlier, that's exactly what I did for you guys. I basically compiled one with a lot of comments where you can see how to declare variables and so on before we move to the next step. Something like this. Let's say I have, let's use 2 floats. We're going to use 2 floats for this example. Float A is going to be our living room. I'm just going to go living room temp, and I'm going to set it to 20.5 degrees. Obviously spell it correctly. My float 2 is going to be kitchen temp, and that is maybe 21.2 degrees. And maybe we also have a dining in there. So float is going to be dining temp, and that is going to be, I don't know, let's say 15 degrees for whatever reason. Maybe it's very close to the door or something. And now what we want to do is we want to create another float, and that float is going to be called average temp across all of them. And we're going to come in here and do the following. So average temp is going to equal, or actually I can also print F to the terminal, and I'm going to say the average temp temperature in the living kitchen diner is, and I'm going to do it in here. So living room temp plus kitchen temp plus dining temp. I'm going to put that in brackets. There we go. Divided by 3. So we do a little bit of maths in here. There we go. Is now going to be average temp. We close it off, save it in, or Control S, run the code, and did we lose something? Oh, yeah, we did. What did we lose? If we look at the syntax again, and if we remind ourselves from the cheat sheet, you can see that I'm saying and I'm declaring that information, but actually percentage F is what we're looking for for the float. And if you want to tell it how many decimal points, you can do .1, .2. But I can just do this, dot, run it again. There we go. So the average temperature is 18.9 degrees. And if you want to, you can add that information in here. Just see, put that here, put that here. You can say .2 or %2. Again, if you're not quite sure, that's where the cheat sheet is going to come in handy, because you can see .2 is a percentage and it's coming before the F. There we go. Perfect. Save this, or actually .1 is what we're looking for. Run it. There we go. The average temperature in the living room or living kitchen diner is 18.9 degrees C. Perfect. Now, what we can do is we can take that example from here, copy it, and now we're going to move into our next programming segment, which is going to be something like this. So why did I use void main? I use void main for one specific reason, because I can now just copy that logic and I can forward it into a programming block in here. So if you just use the program block in here, drop it on the page, it's going to give you a note that only 8 scripts are allowed to be used or can be executed. Say, okay, we're not going to be using more than that anyway. I've put a little disclaimer in here. Please remind yourself every now and again that this is not something that's supported and is going to void your warranty. But if you have, let's say, a Raspberry Pi, other microcontroller or mini server where you can run Pico C, let me show you how easy that can be to translate this testing that you've done in here to the mini server. So paste all of this in here. Keep in mind that I'm not pasting this, the include stdio.h, because I already have it pre-compiled for Pico C in here. And now I'll just empty some space in here. I like it to be, yeah, there we go, a little bit neater. But again, even if I had the space, it wouldn't make a difference. And the only difference in that code is going to be that I'm going to call the main function in here, and I'm going to close it off, save this in, save into the mini server, and let's look at two things. I'm going to start live view. I'm going to come to the plus, click on this, the error text. And now if you've seen start, everything's okay, everything's solid, and it's working correctly. However, let me just break it for you. I'm not going to put that semicolon to see how sensitive it can be. Save it in. Let's see. I hover on top of the error text, and you can see on roll 20, it's expecting a semicolon, or somewhere here, basically it's expecting semicolon. So if we put it back and run it up again, we should be able to see that. There we go. We have a start, which means everything was executed correctly. Now, what you can see in here is that I'm using printf, and obviously I'm trying to print to a terminal. Obviously your Raspberry Pi might not necessarily have a terminal depending on how it's configured. Your microcontroller might not have one. And in this case, the mini server does not necessarily have a terminal that is facing the customer. And now that information is still going to be somewhere. Obviously, it's not going to be lost forever. So if you go to device status and you right click on your mini server in here, you have your show logs app and you have get log file. We are looking for log file in this case. So click on that log file. And once it opens it up, we want to go all the way down to the latest log file. And you'll be able to see, there we go, that in here it's actually giving me that information. And you can see previously, it's saying that in the program block, there was a semicolon expected that is missing. Cool. And then the next time we run the program, it's also telling me, here's the output. The average temperature in the living room is .1 FC. So we do have some kind of a problem and some kind of discrepancy, but if we know the syntax, we can come and change it. Now, in this case, I'm pretty sure that all we really need to do is just do %f. So just do the whole float, C. And then maybe after the C, we can just go, no, actually after the dot, we can go /n, save it in. Let's see if that's what it was expecting. The whole line is okay. Device status. we are looking to again get a log file, go all the way down, and there we go. So basically the slight difference with PicoC in here, in this case, is that it's not actually looking for me to specify how many decimal points I'm looking for the float. It's basically just going to be looking for the float, and then it's going to cut off any remainders, anything that is not necessary automatically. So as you can see, here's my output in here, and here's my output in here, which is exactly the same. As you can see, the average temperature in the living kitchen diner is 18.9 with a dot, 18.9 with a dot. Perfect. Now, there are going to be slight differences, but again, I can show you how to look at them and how to change them. Now, in our case, I want to also show you something a little bit better. So first thing, if you come in here and if you use printf far too much, every single time that you do that, every single time you save into the miniserve or the system initializes, it's going to be printing out or saving in that information to a log file. Obviously, the def log, the log file of the miniserve, is for important stuff. We don't need to know the temperature every single time in there. So in that case, we want to put it in a memory container or something that's going to be more temporary. A good example is going to be either one of these text outputs or one of these analog outputs. So with them, we can either print the text in here. So instead of going to a printf, I can go to that value, or I can go to one of the outputs and I can simply provide that 18.9 degrees in this case. Now, how do we do that? So if you were to go online and look at the documentation for custom scripting, you can also just type in Loxone Pico C online, but then all the way down here, there's a custom scripting document, which is going to open this basically. And in that document, it gives you a lot more information of what PicoC is capable of doing. Obviously, we're going to also try to do things the smart way. So what you want to do from here on is you want to download that document. Just take it. I might already have it. It's fine. I'll just download it again. And now you can go to GPT, and even with the free version of GPT now, we do have the ability to drop that document in here. So I'm going to drop it from my PC. It's here. Open it up. And with this version of Chat GPT, once it reads through the document, I can actually tell it to adjust things slightly. So for example, I can also take my code from here. Oops, Control Z. It will break it. It doesn't matter. I'm just going to run main in here again. There we go. I'm going to copy my code from here. I'm going to tell it to read the document and adjust the code instead of using printf to the terminal. Output the value, the average value, to output 1, and the whole sentence to string or text output 1. Now that will make a little bit more sense in a bit, but basically once it reads through the document, it's going to be able to find out that we do have these commands: set output text, and so on. Now I'm pretty confident that you should be able to use it yourself, because you can see there's this information, void set output. So it's super easy to use that set output information. And you basically have the outputs from 1 to 13 and from 1 to 3 for the text outputs. Now, because obviously it's code and all of the information is done in binary, we start counting from 0 instead of 1. So the very first one is going to be 0 and we go on. But let's have a quick look and see if GPT managed to do the job for us. Now it's giving me, yeah, a little bit more information. It's printf. Cool. Let's see if it works. I'm going to copy this. I'm going to paste it all in here, and I'm just going to trust it. That's going to do the job. I can already see it's doing a slightly bad job. So I'm going to exclude this, the Studio H, because again, we don't need that variable. We don't need that library in there. and I'm just going to call main in here to make sure that I'm going to execute the function, because otherwise it's not going to automatically just start reading it through. Now I save this in, I say okay, save, and if everything goes through with no issues whatsoever, we should be able to see something on that output side. Oh, output 2, hey, there we go. Perfect. Integer, float, double, and something missing in here. So it didn't do it 100% right, but it did manage to get there. Now, I do know what one of the problems is, and you can see printf output, it's trying to output to output text 1 instead of 0, and as I said, it starts counting from 0. So if I just do 0 and save in, it will move to text instead. There we go. And if you look at the float average, where they go, there we go. If I want to put it instead of output 1 to output 3, for example, I can just say 2 in here, save in, and we should be able to see that information on output 3. There we go. With a very, very small exception, and that exception is going to be the strings. Now, strings are going to be outputted slightly differently, and I'm going to show you how to do it. But for now, all you need to know is that a lot of the information that GPT is providing you, you can come in here, drop a little bit of information for either this script, or you can go online and use the whole information for the Raspberry Pi, download that document, drop it in there, and it will already output the information and slightly adjust it for your use case. Right. Now, the only thing that you're not seeing in here is basically the string and the characters. And what I like to do, and what is now an option in GPT, is basically you can take this a little bit further down, so you can see the output. Now, keep in mind, GPT is obviously not familiar with config, but if I take a screenshot of this part with my code and obviously the output, and I go back to GPT, I can tell it debug for me. I can't see the character or string. Give it a photo. I'll give it a screenshot. Load it through. And now GPT nowadays is quite good at looking for that information. So let's go through the code again. See if it's going to manage this time around. There we go, testing characters. So I'm going to copy this. I'm going to come back in here. And again, it's pretty good, but it's not perfect. As we said, you don't need this information. So you don't need to include the library in here. Also, when you come down here, we also need to do one more thing, which is call that main function, because otherwise it's not going to be executed. It's just going to be sitting in there ready for us to use it, but it's not going to be used. I'm going to say okay, save it in, and there we go. So with that very limited information that I gave it, it managed to see that, okay, something is obviously wrong. It also made some suggestions about what is potentially happening with the formatting and so on. And you can see now, I can see my string, I can see the full information, and here's everything that I have on my side. Plus, this code I have in here is going to be very handy. So if I copy it, besides the output text, I can come in here, I can, paste it. And now the only thing that is different between obviously what we have on the controller side, on the mini server side, and this is that obviously our default configuration does not have the set output text, and it does not have the set output in the first place. But instead, we can use the printf in here, and I can just tell it to adjust it slightly. So adjust text slightly for use in a normal C IDE. And we're looking to do basically, instead of set output and set output text, just print to the terminal. So it's going to go through it. It's going to take that information into account. And let's see if it's going to manage to. I'm just going to do it blindly. As you can see, things are happening in real time. So if it doesn't work, it doesn't work. But let's go to this, paste it in here, save it, run our code. There we go. Perfect. Exactly the same outputs. Average value is outputted on its own. And also the whole string is output as a whole, the same way that we've done it in here. Now this is extremely important in here because you can do it both ways. So whenever you do use your code in here, in VS Code, you can create very comprehensive logic and you can test your logic and you can make sure it's working to a terminal. This way, again, you're not breaking your installation, a customer's installation, or even if you have, let's say, Raspberry Pi or a mini server that's dedicated for testing, you're also making sure that you're not stressing that device unnecessarily and potentially damaging it in the process. Now that way, I can come in here and I can write all my code in C. However, once I'm finished, for most of it, I can quite confidently take that information. I can take that file from earlier, which is the Pico C, and I can ask ChatGPT to essentially be my translator and tell it, hey, translate me my C code into Pico C code and adjust it based on the documentation provided. So that way it's now having a better picture of all that information. And 9 out of 10 times, honestly, is going to do a great job because I've tested it, I've played around with it quite a lot. My background is not necessarily that heavily with C. I've done a lot more with C++ and C Sharp. I know obviously the basic syntax of C. However, there's so many differences between one language to the other that the main thing that you need to keep in mind is the logic that you want to build in your mind. And I'm very confident that if you're familiar with config, if you're familiar with building logic with ands or this and that and so on, you'll also be able to kind of create a structure and tell it if this doesn't happen, execute that, and so on and so forth. That is all programming really is. Syntax is only the name that we put things together. It's basically our building blocks, but syntax again can vary massively, and that is where tools like ChatGPT can really help speed up that process. Now we have the basic down, let's go and look at inputs. So first thing, we're going to go back in GPT and we're going to tell it to create the code for Pico C to use the inputs and create the same average sum output. Let's see what it's going to give us. There we go. Let's make it. Okay, now a little bit of an overkill, but it's basically given us exactly what we asked it for. I am just going to make a very small adjustment in this, and I'm going to show you what we're looking for. Now, I'll delete this, and we're going to get some inspiration basically from that code. So if you look at the information in here, it's basically going to tell us that it's going to declare the variables. Now we're going to declare a few variables ourselves. So we're going to do float living room temp, and we're going to give it, that just a declaration in here. Then we're going to make the other float of kitchen temp. Then we'll make the next one, which is float of dining temperature. And now we're going to say that instead of giving it a number or fixed number this time around, we are going to be using the input information for that. So if you look in here, here's the input variables. So you can declare it by just simply saying, let's say living room temp, make sure it's spelled correctly. And that is going to equal get input. I'm going to do 0 because again, we're starting to count from 0 instead of 1. And then we continue with the other ones. I'm going to create the kitchen temp. I'm going to say get input 1. And I'm going to create the dining temp. And I'm going to go and say get input 2. There we go. Now we can create our float for the average, or we can simply copy this. Oops. Now that is calculated at a very, very weird place. So I'm going to create our average ourselves and show you how that works. Now you can already see that it's much easier to compile all your code in the IDE. No second question about it. But if I create it in here, our average is basically going to be, again, living room temp plus kitchen temp plus dining temp, all of that. There we go. Divided by 3. And in here, when it comes to outputs, sprintf is a very, very powerful output that we can use. And sprintf is basically going to print everything, but it's going to print it into memory. So it's going to temporarily print it. It's not going to print it for a long time. Now we can use that, but we don't need it quite yet. We're just going to use the output first. And we're going to say set output. Set output. The output is going to be 0. And the outputs that we're going to be sending in there is going to be average itself. So that, as you can see at the moment, is not very pretty. So we can put a few comments if you want to. So in here I can say declaring the variables and assigning them to the inputs. In here is getting the average, and in here is outputting the outcome to output 1. Okay. Now we need to create 3 inputs at the very least. I'm going to just make 3 constants for now, but we can change that later. Let's go 1, 2, 3. I'm going to give them all just a value. Let's say 17.5. This one is going to be 19. And this one is going to be 19.8, let's say. Save this in. And let's see if we got it. So the average between all of them, 19.8. If I go and change one of them, or maybe another one as well, so you can see the value increase. Save this in. Once it computes, there we go. It gives us a different number. Now, obviously that program in here is not going to be very flexible because it's only going to happen, or it's only going to execute once a change is done. So basically once it's saved into the mini server, once the system reboots, is then going to check that value and is going to output it. But you can already see that we can also use inputs as variables, so that way the information going in is going to be more dynamic. So next section is going to be statements, and we're going to look at 2 types of statements. One is going to be called an if statement, the other one is going to be called a while statement. And basically the if one is going to be the easiest one, the most common one to use, because we're going to say if this and this, or just if this, do this. If it's a different input, a different variable that we're expecting, then do something else. That's quite easy to do and quite easy to configure, and I'm going to prompt it in here. I've already prompted it, unfortunately, but I forgot to record, so let's do it together. I want a C code that is going to prompt the user for the current temp of the room. Create an if statement and say if it's under 20 degrees, switch the heater on, and if it's over 23 degrees, switch the heater off. Let's make it, see if it's going to be good enough. And basically, that's exactly what the if statement sounds like in plain English. If this, then that. So once it's ready, I'm going to copy that code. I'm going to paste it in the IDE. Control S to save. Now a slight difference in here, I'm going to run the file instead of running just the code. And I'm going to open the terminal in here because the terminal is going to give me basically what I'm looking for. And you can see it's prompting me in here as a user to enter the current temperature of the room in degrees Celsius. I'm going to enter 18.5 degrees, let's say. And because it's 18.5, then it looks at the information. It says the current temperature is below 20 degrees, so the heater status is on. If I run it again, I'll run the file. There we go. And I put 24 degrees, for example, the heater status is off. Perfect. Now, once we have that code, we can tell it, oops, let's not miss it. We can go back in here and say, adjust that code for Pico C and make sure that we use input 1 for the temp information and output 1 for the state of the heater. Let's make it up. It goes through its things. It's already looking at the right information. Get input 1. It's making the code, setting outputs. Amazing. That looks good. So I'm going to copy that code. I'm going to go into the program file. I'll drop it in here. Again, probably if you tell it, it's going to stop adding these header tags and it's going to add the main in here, but otherwise we can always add it ourselves. So now you can see there's a float for the current temperature. Getting input 1, again, something to adjust from our side. It's input 0, because again, we start counting from 0, not from 1. There we go. And if you want to set a status of output 1, it's again going to be 0 in here as well. I'm going to set that constant to, let's say, 18.5 degrees again. Save this in the mini server, and let's see what we have. It's 18.5 and output of 1, which means again the heater is actually switched on. And if because it's also using printf instead of using the text output, I'll be able to see in that log file once more. If I go all the way down to the bottom, heater is on, the temperature is below 20 degrees. Again, because it's not ideal for us to use that printer and they're not saved into the mini server, we can tell it that works great. However, instead of using printf output, any text to text output 1. There we go. It says that it's going to be replacing printf with set output text. Copy that, we go back to it, we drop this in. Again, slight adjustment on our side, main in here, with semicolon, save it in, and we should be able to see information on text output 2, because again, it started counting from 1 instead of 0. And you can see the heater is on, temperature of the room is below 20 degrees Celsius, and here's that information. And now it's no longer being outputted directly to the log file, it's being outputted to the text. Amazing. Now with if statements, you can do a lot more, and I think we can do probably another 50 different examples, but you already get a gist of it. Basically, here's how the syntax looks like. First, we have obviously our variables, which we already looked at. Then if we want the user to input information in here, we just basically print to the terminal, say, hey, do this. Scanf is the information, or is the function that we're using to ask for information in here, and then put that information into a float, you can see it in here, of current temperature. And then once that information has been received, then we can say if that information is under 20, heater status goes to 1, and then we output the text basically. Else if current temperature is above 23, do this, and you can see more and more and more information. Cool. Now what we can do is we can also tell it, take the humidity into account, and if the humidity is too high, the heater should also go on. So now it's going to take 2 variables instead of 1. There we go, it goes through. I'll copy this, actually make it as a C code and from the user to input the humidity and temperature. As it goes through, it's going to give it that information, copy it in, go back here, paste it, Control S to save, run the file, and once the file goes through, we're looking for room temperature. I'm going to say 17 degrees, and humidity, I'll say 68% or so. Heater is on, the temperature is below 20, Celsius is above X, and the heater is currently on. And now the only difference that really happened in here is the following. You can see this is saying if this or that, do the following, and in here just using the temperature information. Now a lot of that syntax is already going to be in the cheat sheet again, and you can see, I think in here where we put the if statements, you can see it, but it's very similar to us starting the whole string. Basically, you can see it in here. It's saying if something is less than something else, then you can use different operators. So for example, show me the available operators, if, and, etc. for statements, for if statements. And you can see the operators in here. So double equal means, let's say it's 23 degrees and it's equal to 23 degrees. It's not equal, it's obviously the opposite. If that is not equal to that value. And here's all the different operators you have. And here's the logical ones. And so maybe if you're looking for the temperature to be under 23 degrees and the humidity to be under 60, you're going to be using something like this. If this and that is true, then proceed to the next level. All operators and not operators for everything else. So basically, if something is not true, then continue on. And you can also invert the condition quite easily this way around. Now, for a lot of this information, there is a little hint. If this is looking too complex at the moment, it's fine. Don't worry about it. The one thing that you want to do is you can always tell ChatGPT to explain it to you as if you were at a different level. So for example, you can tell it to explain to you at university level, or all the way down to as a 5-year-old, the way that you're going to be able to visualize it and have a use case that is probably going to be easier for you to grasp. Now, on the other hand, it also does it on a very high level. So for example, if you're already very familiar with logic, I assume you're already very familiar with stuff like AIs. But in here, what you can do is you can tell it to just give you a very brief summary of the basics and just show you how the syntax looks like. And then everything else you can just kind of control yourself, and you can create the variables and whatnot. So once we're happy with this, I think we can move on to the next one, which is while loops. Give me a simple while loop example in C. There we go. Let's copy that. Paste it in the IDE. Control S to save. And now we want to run the file. Enter a positive integer, negative integers to exist. Cool. I'm going to put 5. Enter a positive integer, negative integer to exit. 5. So as long as I am putting a positive integer, there we go, everything is fine. But if I put -5, there we go, the sum of our positive integers is 29, and it's currently -5. Now, that in here, I already know what it's doing. Actually, that is probably one of the most common cases. Basically, it's creating the sum of the numbers. And every single time I keep on adding a positive integer, basically as long as it's true, as long as it's a positive number, it keeps adding up to the sum. So it's iteration, and every single time it adds more and more and more on top. So if I kept on going, it would give me the last number. So for example, if you're adding +2, +3, +4, at the end it's going to give you a sum, which is like 12, 13, or whatever it comes to. As soon as you break the rule, so as soon as that is not true, basically, it's going to break the whole program. Now you can use that exact same logic in here for other things, and I'll say both for loops and while loops are quite common. So basically you can look at the temperature and you can say while that temperature is at X, keep on checking, keep on doing something, keep on executing the whole program. When it sees the change, then it will then basically break and start doing something else. Now that we know about if statements, else statements, and while loops, the next thing to really look for is going to be input events and events in general. Now, obviously for something like a Raspberry Pi, we have a lot of inputs and outputs, something like a mini server, something like any other microcontroller. Obviously, every single time a value changes, you want to be able to do something. So you want to be able to listen for that event, and when that event occurs, then you want to execute an action. For example, it can be as simple as the temperature changing from one point to the other, maybe going from 22 to 23 degrees, and then you want to execute a change. And instead of using a while loop saying while the temperature is X, then we can make it a little bit more dynamic. So maybe a button being pressed, maybe there was a trigger that we added in, and that trigger can basically say, hey, there was an event. For example, if I was to use my mouse and click on it in Windows, that is a mouse click event, basically. So every single time I click it, I have specific information being shown to me. If I right click, it's going to give me a right click event, and so on and so forth. So exactly the same thing we can do with automation and with a lot of our microprocessors. So if you were to look at something like this, I'm going to show you a very, very simple example in here. Now, when I say simple, it might not be necessarily the simplest, but let's look at this. I'm going to explain it to you now. Now, if you look at everything that we have in here, exactly the same. We're declaring our variable. This I've said is going to be a float, so it can have decimal places. And basically, we have this information here. We have that function that's already built in into PicoC, which is get input event. Now, get input event is basically listening for anything happening on the input side. And if there is a change, we can notice that change. And if that change is not 0, so basically if there was a change, this is going to get triggered and it's going to basically get the information from my input and it's going to trigger it to the output side. At the very bottom, we do have a little sleep, and that sleep is basically so the CPU does not run 24/7, executing the same command over and over again. At the moment, for testing purposes, maybe 15 seconds is a little bit too high, because you can use sleep for milliseconds and sleeps for seconds. But if I do 3 seconds, for example, I'll save this in. Let's see if I'll be able to show it to you. So you can see at the moment, input is 10. There's no changes. The code does not output anything. But as soon as an event happens, so maybe a value changes, I'm just going to change it to 10.5 or 05, let's say. There we go. It checks in. Then I'm going to go to 15. I'm going to go to 20. It's going to keep on checking if there's a change on my input. Oops, that value is not legal. I can even go to -20, or I think -5 is what I gave it. There we go, -5. So every 3 seconds, or if not a little bit faster, because it's already checking again and again and again, it's going to change that information to the output. So now in here, if I was to have something like my heating logic, I can basically say as long as something does not change, you can run it and then you can stop, or you can stop for a while. So if I was to increase this number to, let's say, 100, I'll save it in. I am saving more resources. So I'll put this to 10 again. Because now it's not going to be constantly checking. Actually, I'll put it to something else. So I'm going to be constantly checking because it's taking that sleep cycle. So in about 2 minutes or so time, we should be able to see an output in here change. Now, that is perfect for obviously saving resources, or the other way around, if you want the system to be executing very, very quickly on every single change immediately, you can basically get this down to 1 second or 1 millisecond or 10 milliseconds or something like that, and then the value is going to be changing pretty much immediately. So if you are controlling something that is more sensitive to time, you can do it this way. Now, for events in particular, I'm going to give you a couple of examples. I'm going to put them in that cheat sheet, and in there you'll be able to see what 0x1 means, 0x2 means, and so on. But basically, I've prompted it in here for you guys, because I can also copy that chat and I can share it with you. You can see that depending on the input event, I can check if it's 0x3, 0x1, and so on. So instead of me checking if there was a change on all of these inputs, I can check if there was a change only on one of these inputs, maybe input 2, input 3, or maybe a combination of them, and say only if there was a change on them, then do something, then execute the program or run it again instead of doing all of them. So events, very, very important. And of course, this is going to be something that you're using quite frequently, but as you can see, it's really just an if statement. It's just checking for events. And if there is an event, we're going to execute something. And then here comes the exactly same logic that we were building up to this point. Nice. Right. So the next thing that we're going to look at is something like this. I've already created it. It's about 40 lines of code, but it's basically using a lot of principles that we're looking at already, basically storing information. And let's see how everything kind of compiles into one thing. So we've already looked at how to make a big string and how to basically make a text file. Now, as you can see in here, here's going to be our output text. I've currently limited to 101 characters, but you can make that more dynamic if you want to. Or you can make it bigger or smaller depending on how many characters you need. There is the input length, there is the passing through information and so on. So basically us using different commands. But all that this is doing, it's going to be looking at the input that I'm providing it. Then it's going to be using an HTTP GET command, and it's going to be getting the information for the URL and path, which I've already provided in here as URL and path. And then depending on what I've given it, it's going to search for a specific part of that content once the information is returned, and is going to fetch the first 100 characters in this case. So what I've done for this example is I've gone online and I just said free API, no key required. I usually go to something like this, which is a free public list. And if you look down, you can find a lot of different ones. I have used CoinGecko and CoinDesks in my previous videos. I have used weather information in previous videos and so on. It really depends on what you need. If you want to get your public IP and so on, you can. I know this one works quite well. Same with the rest. For now, let's look at something easier, something more fun. I think there were the quote ones that we used in this example. So if we look at inspiration, quotable, there's quotable. Let's go. So if I open it up, it generates a random quote. That's what this domain means. And I'm going after the content and I'm looking for the information straight after it. So for example, friendship is not a marriage, rah, rah, rah. Okay. If I look in here, you can also see that I'm searching for content and I'm saving that information into a buffer. As you know from earlier, we are using that string copy instead of, again, printing to the buffer every single time, printing to the get log file. And I'm just outputting that information to the text file directly. If I save in again, it's going to run it again. It's going to give me a new quote for the day. Save it in again. It's going to give me a new quote. So for example, with something like this, if you have, I don't know, let's say audio, you can generate a quote every single morning whenever you get up through a text-to-speech or something like that, and you can make pretty much anything you want in the house happen. But obviously, more importantly, let's say you're grabbing some information from an API online. Now you can store that information into a variable, any variable. That can be just a text variable, that can be a string, and then you can manipulate that data to anything you want to. So for example, in some cases, there's a limitation where you want to first fetch an API key. Once you have that API key, then you want to make another GET request, and that GET request is now going to be giving you the real information. Now, instead of that happening with virtual outputs and you save it into the mini server, then once you save that file, reading it with the virtual input, all of that can happen within memory allocation, which means that you can create what is called a buffer. A buffer is essentially just a very long sentence, a very long string that you can have. And in that buffer, you can save the information that you need, then move on to the next thing, to the next thing, to the next thing. And once you're ready, you can basically free the response, or you can free that memory allocation that is being used, and you can make sure that that memory is used for something else. And that way you are saving your SD card because you're not reading and writing far too many cycles. You're also making sure that the information that you need is digested and everything else is dropped. Now, that is one example, and I have quite a few different examples in here that I've created. Some of them are simple, some of them are more comprehensive. But long story short, there's a lot that you can do with Pico C. I have played quite a lot with things like Raspberry Pis. With Raspberry Pis, it's also very similar. However, with Raspberry Pis, you have even more that you can do in terms of you can also program specific ports. So GPIO on Raspberry Pis for things like RS-232, Modbus, and so on. And you can look at frequency, you can manipulate that data and do something else with it. You can also use this in here for streaming content, streaming out, or reading information from, again, things like RS-232, RS-485, and so on. And all of that is very, very powerful, especially if you know how to do memory allocation. There's things like pointers in the language. I'm not going to go into that much detail in this video, obviously, but maybe we'll save it for a future topic. Now, hope this gave you the right tools. And if you were to take one thing from it, it's going to be hopefully GPT for me. Now, in here, you can ask it as many questions as you want to. If I've gone over something way too quickly, you can just come in here, ask it to explain it slower, or give you different examples, or even break the code down even further. But any questions, feel free to ask me below. I hope you enjoyed it. See you in the next one. Bye.